Hello friends, welcome back. Today we're going to discuss the idea of regression analysis. Now, if you recall from your reading, regression is a way of making predictions about one value using another value. So we have an independent variable along the x-axis, and we use that x-axis variable to predict the y-axis variable, the dependent variable. So in this case, we have, let's say that we are a manager and we are considering expanding our operation to a new market. And we're trying to figure out just how large of a space should we plan on leasing at the new location. So I have here a list of 9 offices that we already have operating. Imagine these might be a retail establishment here. We have the size of our building, and we have the estimated size of the market with which we are opening our new office, our new shop, as it were. So we're going to use the size of the market as our independent variable to try and predict just how large of a space we should plan on leasing if we use our other locations as a guide for what's a good size of a building. So we'll take this data, and the first step we want to do is actually just plot the data. Step 1 is plot data. Now this will be very useful in just getting a feel for, is there a pattern in how the data is structured, and just give us some insights to begin working with it. So we'll go ahead and highlight those. We'll do insert chart, and we'll use the XY scatter with no line. So we can see here that on the bottom axis here is the market size, and this is the building square footage. We see there's a positive correlation. So as the x-axis variable goes up, the y-axis variable also goes up in response. So that's interesting, and that kind of makes sense. Obviously, the more people you're trying to service with your store, the larger of the building square footage is probably going to be required, so that it makes sense. So let's go ahead and try and improve our chart a little bit, make it a bit prettier so that it's just more informative. So press this button here to add some axes. So now we have on the x-axis again, this is the estimated market size, and here we have building size in square feet. Excellent, here we go. All right, so now we have that. I'm going to show you a trick now that Excel does, and it's going to give you a lot of a hand up into trying to solve our problem today. So if we right click on the data set on the chart, we have an option to adding a trend line. So now we have these options here. I'm going to say linear, which means just a line, and you can see the trend line is already there, so you can go ahead and close that off. So you can see now this is a fitting of the best fit line through the data to make sense of it. This is actually the precise thing we're doing now. This give you the reason we're doing this exercise is to give you an understanding of what Excel is doing when it calculates this information here, and that way it's less of a black box. It's more understandable to you. So we have the first step done. Now step 2 is going to be build the regression table. Okay, so like we did with the last exercise, we'll start by copying this into a table down here. You don't have to do that. It's just help make it easier for you guys to follow. So now we have estimated size of the market and the building size. I'm going to add 2 more columns here. Okay, so we'll go ahead and make boxes here. And I'm also going to add a new row, which would give us labels. So we have X is our x-axis value, Y is our Y-axis observation value, And now we'll have one for x times y and another one for x squared. Remember, we have to highlight that too. Right click to format cells and add a superscript. So now we have an x squared column there. We'll center those. And now we'll just go ahead and do what the equations say. Equal x times y, and then equal to x caret 2, or x to the second power. We'll copy that and we'll bring this all the way down here, and we will have all of our values propagated. Now, we will add sums for all of these columns. I'm going to cheat a little bit and save some time by plugging in what I've already have copy over to the side here. And we'll just go ahead and add sum of all the values in that column. And we'll copy that over as well. Very good. And now, last thing I want to copy or to enter into this table here are the mean values for x and y. So that's average of all these values. Okay, so I'm going to go ahead and reduce the decimal point there, so it's just a little bit easier to manage, easier on the eyes. Okay, so now we have a full table here with all the numbers we need to perform our analysis. Okay, well, on to step 4, or pardon me, step 3. Step 3 is develop the regression equation. Now, we all know the equation of a line. From going back to algebra back in elementary school is, well, y equals mx plus b. So something similar here. Our equation is going to be y hat, which is our prediction, is ax plus b, where x is going to be the market size and y hat is going to be the estimated building size for that market in square feet. Now, I'm not one to like to make you memorize a lot of equations, but there's one that is particularly useful for this exercise. So we'll go ahead and I'll give this to you now. It is the equation for A. A in this y equals ax plus b. This is the equation for it. And you'll notice that all of these items here are already calculated for you in the previous table. N is the number of observations. Sum of xy is this number. Sum of x, sum of y are both here and here. Sum of x squared is there. Sum of x squared. All these numbers can be very easily calculated by doing that calculation. So we'll go ahead and do that. A is equal to, and I'll make this a little bit bigger. And we will actually do the calculation for this. Make it easier for you to follow along, making the font a little bigger. So equal. We're going to have a numerator and the denominator, so let's put the top one in quantities and the bottom one in quantity here. So we'll have open quantity, we'll have n, which is 9, times the sum of xy, which is there, minus, actually, close that quantity, minus the sum of x times the sum of y. All of that in one quantity divided by, again, open quantity, 9 times sum of x squared, which is right there, minus the sum of x to the second power. Close quantity, and our number there is 6.36082. What's that number? Now that is A, so that is going to be the slope of that line going along the x-axis there. So it's going to be going up. Every additional person in a market is going to cause a 6 square foot increase in the estimated building size. Okay, so that's part one of the, we solved one of the unknowns. Now we have to solve for B. Now there is an equation for B that you probably find in the book and you'll see elsewhere on the internet, but I don't like memorizing other equations if I don't have to. So in this case, I'm just going to think through this logically. B is going to be equal to, so it's going to be equal, if we know the slope, and if we can find one point on the line, we can use that slope to follow itself back toward the to the y-axis, or to the vertical axis. So what is the point that we know is on the trend line? It's going to be the intersection of the two means. So if we have x bar and y bar, that's going to be a point on this distribution, on this graph. And we plug in our point there, and from there follow using the slope of A back toward to the y-axis. That will lead us to what our the y-intercept is going to be, or what the value of B is. So let's go ahead and do that. Let's go ahead and make this font size a little bit easier to read. So we'll start with y bar, which is the y elevation at the mean, minus the slope A times whatever x bar is. So we'll say x bar. And we'll go ahead and calculate that now. So equal to y bar, which is this number here, minus A times x bar, and that will give us negative 2819, or thereabouts. Okay, so that's our x-axis. It's going to be negative 2819. We're good to go. All right, so now we have the A and B solved. Now it's easy for us to make our prediction. Okay, step 4. Make our prediction. Okay, so again, we know our equation. It's going to be y hat equals ax plus b. So we'll go ahead and we will insert the symbol for y hat, which is right there. And that's going to be equal okay. So our prediction, well, remember, we're trying to figure out what our size of our facility would be with a market size of 10,000. So we can plug in for x 10,000. So we now have A times 10,000 plus our B. So if we actually plug in these numbers here, this is what the equation is going to look like. Okay, that makes sense. 6.082 and the negative 2819, those are those numbers plugged in there, plugging in 10,000 for x. And if we do that, we'll go ahead and again we'll solve the equation. Is equal to A times 10,000 plus the negative 2819 will give us 60,788 square feet. And that's basically the prediction here. So now we can go ahead and use that as a basis for looking for our new leasing spot. Looking for a new spot, roughly 61,000 square feet should be fine for our 10,000 person market. Now, this is the calculations. I'm going to show you a way to check your work. Remember this trend line we did a while ago? if we right click on the trend line, we can say Format Trend Line. At the bottom here, it says display the equation on the chart. And lo and behold, the same equation we just calculated is right here. Minus 6.36, or the A of 6.36 and the B of negative 28.19. So this is a great way to double check your work. The other thing to look at here is to display the R value. R squared is equal to 97.77. So what does that mean? The R value is the degree of correlation. And if you square that value, it tells you how much of the variable in Y is predicted, is explained by the change of X. So that any number, depending upon the usage of the equation, if this number is 0.3, 0.6, or even up to higher than that, these could be various level of utility. It's more useful the higher that number is. In this case, this relationship, this equation explains 97.77% of the change in Y based upon the equation, based upon a change in X. It's a very good model of what's happening here. So this would be a fantastic model for many purposes here, but no model is perfect, which is why only if you get to an R squared of 1.0 does the model perfectly explain what's happening. But it's still very useful and a good model to keep in mind. So when you're interpreting these equations, knowing that the R squared value, to what fraction that explains information, is a useful way to evaluate how good your model actually is. So that is enough for this example here. It's a good example for you to model from. Now for our assignment now, for this week, I'm going to use the same tool here in a new problem. In this case, we are going to make a prediction of sales. So this is the problem that's in our homework, where we have a certain number of years in a row, and we are actually going to make an estimate of sales for 2020 based upon the sales of previous years. So I hope this will be a relatively straightforward problem for you. Any questions, let me know, but otherwise I will see you in the next video. Take care.